Hello everyone, welcome back to our channel Nursery to Varsity. In the previous tutorial we have seen 3 questions based on while loop. And now in this tutorial we will see 3 more questions based on while loop. Question 1. Write a program to check whether a number is palindrome or not. Question 2. Write a program to find the HCF of 2 numbers. And question 3. Write a program to check whether a number is perfect or not. So let's start with our first question. Write a program to check whether a number is palindrome or not. To solve this problem, first we need to know about palindrome number. Basically, a palindrome number is such number which when reversed is equal to the original number. That is, if we read the number from left to right or the right to left, it will comes out as same. For example, the number say 1, 2, 3, 2, 1. If we read it from left to right or either from right to left, either from this side or this side, it will result out as the same number. And this is what we call palindrome number. Let's take another number 2, 1001. Again, if we read from left to right or from right to left, it will read as same. So, the palindrome numbers are number which when reversed will give the same original number. By finding the reverse of a number and comparing it with the original number, we can find whether a number is palindrome or not. If original number and reverse number are equal, then a number is palindrome, else not. We have already understand the program of finding a reverse number in our previous tutorial. If you have not seen, you can go and check it out. And in this program, the new thing is just a comparison. So let's quickly recall the concept of the reverse number. That first we have to find the last digit and then add it to the reverse variable. And second, we also have to increase the place value by 1 by multiplying 10 to the reverse. We need to do is find the reverse, which is nothing, reverse into 10. We are increasing the place value and by adding the last digit of the number by n modulus 10. And after processing the last digit, we have to divide by 10 to the n to remove the number. And we have to iterate this task until n is not equal to 0. And by this we will find the reverse number, and after that we will check reverse number is equal to the original number. If it comes out as 2, then it is a palindrome number. If it comes out as false, then it is not a palindrome number. So this is the simple logic. So let's start coding. So by including the libraries #include stdio.h int main, we need 3 variables int n, that is the input from the user. Num will copy our original number in this and reverse rev, it is equal to 0. We are initializing it with 0. And now we need to take the input from the user, enter a number, scanf %d and %n. Now before finding the reverse of a number, let's copy the original number in our variable num. And why we are doing so? Because at the end of the loop, the value of the n will change because we are decreasing it every time in our loop. Let's start with our while loop. While n is not equal to 0. This is the condition. And in this, we will find the reverse into 10 plus the last digit, which is nothing but n modulus 10. And after processing this last digit, we need to divide it by 10. Basically, we are removing this last digit. We have to iterate this until this n is not equal to 0. And after the while loop, we need to compare. This is the new thing. If the rev is equal to num, then that means printf a number is a palindrome number. Comma num, else will print %d is not a palindrome number, and at the end return 0. And that's how we have completed our program. So let's build and execute our program. Enter a number, say 1, 2, 3, 2, 1. And 1, 2, 3, 2, 1 is a palindrome number. And the result is true. So let's close it and check another number. So let's again build and execute. Say number 2, 3, 4, 5. And 2, 3, 4, 5 is not a palindrome number. The answer is correct. So let's close it and move to the next question. The next question is, write a program to find the HCF of two numbers. So hope you are familiar with the term HCF. I suppose you have learned HCF in class 5th. Okay, in this program we have to code to find the HCF of two numbers. So let's recall what is HCF. HCF, or we can say highest common factor. Highest common factor. There are other names too for HCF. There is a GCD, greatest common divisor, or GCF, greatest common factor. Now suppose we have say two numbers 6 and 12. 6 and 12. The factors of 6 are 1, 2, 3 and 6. And the factors of 12 are 1, 2, 3, 4, 6 and 12. Now, what are the common factors between the factors of 6 and 12? That is 1, 2, 3 and 6. These are the common in both the one. Now we need to find the highest one. So we can easily see the highest one is 6. So the answer is 6. That the HCF of 6 and 12 is 6. Now we need to build the logic for finding the HCF. First, we will take input from the users, say N1 and N2. So we will take two inputs from the user and first declare and initialize a variable which is used to hold the HCF. So let's name it as HCF only and declare it at 1. If nothing is common between two numbers, then 1 is the only answer. And that's why we are initializing it with 1. Then we need to find the minimum of two numbers N1 and N2. We will find the minimum of N1 and N2 so that we can iterate our loop up to that only. And then we will run our loop from 1 to minimum. And inside the loop, we will check if I is a factor. If I is a factor of two numbers, that means I exactly divides the two numbers. If that's so, then HCF is nothing else but I. What I am trying to say is, we will check if I is divided by N1 and if I is divided by N2 simultaneously, then HCF will be the I. And at the end, we get the highest common factor. So this is the logic for finding the HCF of two numbers. So let's start code the program. First, we will include our library stdio.h int main. Then we need variables N1 and 2, I, which will start from 1. So let's initialize here only. And we need to find the minimum between N1 and N2 and our HCF. So we'll initialize it at 1 only, which we have already discussed why we are initializing it from HCF equal to 1. Then we'll take the two input from the user, enter two numbers, scanf, %t, ampersand N1, ampersand N2. And now we need to find the minimum among the two. And here we are using the conditional operator. If N1 is less than N2, question mark, then answer in minimum should be N1, else N2. You can learn this conditional operator in our previous tutorial. In the while loop, we will apply the condition I is less than equal to minimum. And that's why we have find the minimum here. Now what we have to check that if I is a factor of both number, and how we will do this, if N1 modulus I is equal to 0 and operator N2 modulus I is equal to 0. Then what we need to change is HCF is equal to I. And after that we need to print HCF of %t and %t is equal to %t. The first format specifier should be N1, N2, HCF. Return 0. Initially I is equal to 1. So we are starting from 1 only and we are checking from 1 from both the numbers whether 1 is divisible by 2. After that we need to increment our I. I is equal to I plus 1 up to minimum number, so that it find the greatest common factor in that. If we did not include I here, then our loop goes to infinity. So we have to take care of that. So now let's build and execute our program. Enter two number, say 10 and 15. HCF of 10 and 15 is equal to 5. We can recheck our answer by using that factors of 10 are 1, 2, 5 and 10. And factors of 15 are 1, 3, 5 and 15. So what are the common factor? 1 and 5 here, 1 and 5 here. And what is the highest one? The answer is 5. So we are getting the answer correct. So let's close this program and move to the last question of this tutorial. The last question for this tutorial is write a program to check whether a number is perfect or not. To solve this, first we should know about the perfect number. A perfect number is a positive integer which is equal to the sum of its proper positive divisors. Let me explain you what does that mean. Let's take a number, say 6. So 6 is the perfect number. How we can say? The proper divisors of 6 are 1, 2 and 3. It does not include 6 itself in the proper divisor. So the sum of the proper divisor, it comes out as 6, and therefore 6 is the perfect number. Now the logic for the perfect number is very easy. We have to take input from the user, say n, and then for calculating sum of the divisor, we need another variable, say sum is equal to 0, and initialize it with 0. Now we have to check each number with our input number, that number is divisible or not, or the number is divisor or not. So the loop condition will go up to n, but no, the loop condition will go only up to n by 2, because a number have proper divisor only up to the n by 2 and not greater than that. And inside the loop, if I is a positive divisor of n, then we will add to its sum. So we will apply a loop and we will apply the condition of I is less than equal to n by 2 to n by 2, and inside the loop will sum our addition if and only, and inside the loop will sum I if I is a proper divisor of n. And finally we have to check that if this sum is equal to our original number. If it comes to be true, then it is a perfect number, and else it is not. So this is the simple logic, and now we can start coding. So let's start with the basic steps, including the library #include stdio.h int main. Then we need three variables, n, sum, and initialize it with 0, and I, which will start from 1. Then we'll take the input from the user by printf, enter a number, and scanf %d %n. Now we need to apply the loop and calculate the sum. We have already discussed what would be our condition, that I should be less than equal to n by 2. And why so? Because the proper divisors will include less than the n by 2 only, and not after that. So we'll check each number, each I by n modulus I is equal to 0. If that's so, then we have to add in our sum, and in that way we are adding every divisor between n by 2, and after that we have to increase I by 1. Okay, now we get our sum after the end of the loop, and we need to check our sum with our original number, that if sum is equal to by n. If that's so, then print %d is a perfect number, else printf %d is not a perfect number, n, comma, and again here, and after that we'll write return 0. And by this we have completed our program. Hope you have understand the logic. So let's build and execute it. Enter a number. So let's say 6, and 6 is a perfect number. See, 6 is a perfect number. You can check it. We have already checked it that the proper divisor of 6 are 1, 2 and 3, and the sum of 1 plus 2 plus 3 is comes out as 6. Now let's take another number, say 10. And 10 is not a perfect number, because the divisor of 10 comes out as 1, 2 and 5. And the sum of 1 plus 2 is 3 plus 5, 8, which is not equal to 10. So 10 is not a perfect number. So that's all for today's tutorial. In the next video, there are a few more questions based on while loop, which we will discuss. Hope you have enjoyed this tutorial, and if you found any queries, you can either comment in the comment box or mail us at nursery@gmail.com. Do follow our channel Nursery to Varsity on all our social media handles. Keep liking, keep subscribing, and do not forget to press the bell icon. Thanks for watching. Stay tuned.